Hello and good morning, ladies and gentlemen, also from my side to the second day of Formnext 2022 here on the AM4U stage and at the screens at home in our live stream. We are kicking off a day full of interesting panel discussions and experts' insight, as well as highlights and sounds from the exhibition halls. Together with Frank, whom you have just seen in the morning talk, we are going to be there for you in order to answer your questions you might have. So please make heavy use of the comment function in our live stream, and I will get your question here on stage to ask it to my audience. Let's start the day with a really interesting panel. I recently heard an interview of Terry Wohlers, who made a very fascinating statement regarding 3D printing. He said, the size of the product to be created is not important for the time being. The basic principles of additive manufacturing apply regardless of the size. So this brings us to a topic that has developed rapidly in recent years, the use of additive manufacturing in the design, planning, and construction of buildings. The focus here is on important aspects such as sustainability and circularity, whereby it's not only about recyclability, but also about the possibility of deconstruction and reuse at another location. So in order to be able to approach such a topic, I need, of course, experts of the area, and we have a lineup here on the panel that can definitely be considered as experts. So please welcome with me on stage, to my left, Dr. Olga Ioannou, not so easy, Assistant Professor, Architectural Engineering, Technology Department, Architectural Engineering, it's doubled, at the TU Delft. Great to have you here, Olga. Then we have Professor Dr. Paul Nicholas, Associate Professor at CETA, the Center of Information Technology and Architecture at the Royal Danish Academy. Great to have you here, Paul.
Thank you.
And then Dr. Oliver Tessmann, Professor of Digital Design in the Department of Architecture at Darmstadt University of Technology. And then last but not least, just arrived on time, Dr. Nadja, your name is quite heavy to pronounce. Let me...
Guadilliere-Jami.
Okay, I try to do that. I stay with Nadja if you don't mind. So you are a postdoctoral researcher at the Technical University of Darmstadt as well. Hello everybody, great to have you here. Olga, starting with you, because your main topic is circularity, right? So the construction industry, as I read, is responsible for a large share of waste. I was quite surprised, to be honest, because it's the first time I really considered the topic of waste. I've read like 20 to 30% of the whole waste of the European Union is produced by construction. So it's then even more important that we reuse things and we can recycle materials. So what does that play a role in your work, in designing, and in your work at the university?
Well, we are trying to establish new design protocols for reuse. That's not inherent in the architectural profession. Layers are still very interdependent, building layers, I mean. And therefore, we are required now to come up with different ways of designing building products, but also buildings, to be eligible for reuse. That means that requires a major shift from buildings as monolithic structures to buildings like assemblages, so assemblages, in the sense that buildings are temporary, let's say, formations of products that have otherwise a very high value, a higher value than the building itself, because they can be reused endlessly in endless life cycles.
Is it kind of a modular approach then, in terms of the elements, or...?
Yes, but that doesn't mean that it limits design.
Yeah.
It kind of challenges design to overcome modularity per se.
Very good, very good. I come back to that topic because that's really interesting for me. Paul, when we talk about optimizing and reducing waste, because this is important, we quickly come to the topic of material use and reuse. To what extent are you involved here with your research and what you are currently working on?
Yeah, so I suppose that we looked at large-scale AM as an enabler for new materials for architectural building. And we are working particularly with biodegradable materials, bio-based materials, materials which come almost entirely from local waste streams, agriculture, the timber industry, the meat industry, the clothing industry. And we're very interested in working with and developing materials using those products, which are locally producible and, most importantly, very cheap. We're then working with robotics and gantry scale printing to print large-scale architectural elements. From those, we can print elements at the moment that are about 2.5 by 1 meter, which can weigh up to 60 kilos or so. And we're also interested in part of that question of scaling up of those materials, not just being about the size of the printer, but also the ability to produce those materials in quantity. So ideally, being produced cheaply, easily, in situ, on a site and with little energy. And then lastly, we're interested in the performance of architectural elements that are made from those materials. And I think here what we are understanding is that it would be maybe a mistake to consider them as one-to-one replacements for many of the materials that we have around us. But what we need to do is to identify the particular opportunities associated with those materials. And that's particularly also around the way that they can modulate the internal climate of buildings, also the acoustics, many qualities that other 3D printable materials can't do.
So it's not rather about stability or material specs that are similar to the ones we have today. It's more about the specific use in the future where you can put them in the building, right?
Stability is important.
I mean,
of course.
Yes. That would be my question if we're talking about these materials.
Yeah. But I think it is very much, yes, looking at what other value, what extra value comes with these materials beyond those that are sort of currently in our printing palette.
Yeah, very good. Thank you so much. Nadja, you are not only doing research. I was quite interested in to see that you have founded X-Tree. That's a company that prints large formats. And you have already existing project, right, as far as I read. The question always in additive manufacturing, whatever panel discussion we're doing, what are applications? Can you name one or two and give us the current status for the use of 3D printing in your field?
Yeah, of course. I can give 3 examples from X-Tree. So they're all in concrete, but the first one is furniture. So we've explored a super large range of furniture. The second one is housing. So we just finished a series of 5 houses in the north of France. Which are quite interesting because they mix concrete printing with a range of other building techniques. And so this is where applications for the construction get interesting, right? Because you're able to really see how it connects to the whole rest of the industry itself and the techniques they use. And the third one is slightly further away, but also extremely interesting, is artificial reefs for fishes. So with the geometries you can print with 3D are especially complex compared to other concrete structures, and so you're able to provide housing not just for humans, but actually for animals too, including fishes.
Okay.
So yeah, here is a maybe broad range, but that's also the thing with 3D printing. You can do a lot of stuff with it, so quite a few applications there.
So what is then the focus? That would be an interesting question, because we kicked off with sustainability and circularity, and I think you all are in architecture, so there's always also a design approach. Is the focus rather to create the perfect solution regarding sustainability or design, or is it a mix of all?
That's a big question. I would say it just started being mentioning, and we have quite a few people here working on that. It's that idea of assembling 3D printing with other pieces and also disassembling. But yeah, Oliver, maybe you can say a few words about DDU's work on that.
Yeah, well, we have an interest in what we heard from Olga already, to work with modular systems, but revisit those from a digital perspective. If you use computation for modularity, we hope that it looks different from the disappointing post-war Plattenbau stuff that we find all over Europe. Yeah. So using computation for combinatorics, recombinatorics, is something that allows to really design with modular principles. And that also addresses the question of the scale. Do we always need a printer that has the scale of a house or is slightly bigger to print the entire house? Or can we prefab stuff that is assembled and can be disassembled, but also can be reused in different contexts and buildings.
Yeah, that would be interesting for me, because then aren't we then back again in like delivering parts of a ready house and assembling them on the spot? Wouldn't that be contradictory to the sustainability approach of at least try to prevent transportation, for example, in this case?
What's important to have in mind is that the construction industry is very different from a lot of industries we see here at Formnext. It's extremely fragmented. You have small companies doing stuff. You have a few global players, but a lot of them are small scale. So that means every construction site is slightly different. There is stuff that is prefab and is brought on site. But there's also the case that machines travel on site to then print the entire building. And I think we have to look at all the different possibilities. And then if we look at life cycle assessment, sometimes it's also about the length of a transport that makes things sustainable or not. So in that sense, keep the possibilities open still. I think for us as researchers, it's important.
Oliver, you helped to establish Beam. I mean, you are one of the founding partners. So you have a good insight and overview of all the architectural activities through your international network. What has to be done, as you mentioned, the fragmented industry in the construction area, what has to be done to bring 3D printing in the real production world so that we get it at a scale and not only like experiments or single projects?
As you mentioned, we are running the BEAM Symposium, which stands for Built Environment Additive Manufacturing, and that starts at 11 o'clock in the Tour House, so you're all invited to join. We do that since 2015, and it's very impressive how things evolved from kind of concrete poo in 2014 to, well, houses, multifamily houses being built in 2021 and being presented today. What we see is, on one hand, that there are companies that develop 3D printing of concrete into a robust technology. You can use it. And there's an approach of gaining efficiency of existing things that have been built. Do them a little bit more quickly, let's say. But what I think we also need is a kind of disruptive change, which is in German the Bauwende. We have to rethink the way we build and how we consume materials and how we reuse. So we have to look at materials that we are printing with. Can we print with local materials, where you bring the technology to a place and you use the local materials? Can we use biomaterials for printing? This is something that research now has the opportunity to focus more on after the technology is working. The printers are there. We can now look at materials. We can also, and we still need to do that, at design to production workflows. We have other possibilities of forms, geometries that can be printed. Well, we also need to design them, right? So from an academic point of view, it's also a question of educating a new generation of designers, architects, engineers to have a deep understanding of the link between designing and materializing printing elements and buildings, of course.
Very good. Paul, Oliver just mentioned the materials, and you were talking about the biodegradable material. When we have, like, as far as I read, like, we have concrete, we have sand, we have different materials. What are the most common ones used in 3D printing, and what are the different challenges regarding the materials?
Within biomaterials?
No, within 3D printing.
3D printing in general.
So what is the most, let's say, the most trendy one for the moment?
Well, certainly in Denmark it is concrete, I think, at the moment. Cobod is a Danish company, a leader in the industry for large-scale gantry printing, and it's also a partner in a number of our projects. It's very interesting for us to test our biomaterials against an existing infrastructure, which is their 3D CP gantry printers, and to understand how that those processes work. I think also, I mean, there is Yeah, probably concrete, maybe metal, and maybe polymers, so PETG, these kinds of things. But I think from our research focus, the interest is really in trying to diversify actually materials and to think about how can we use more different materials so that if we do not need to print with concrete or metal or plastic, then we can print with another material as well. I think, Ollie, you mentioned scale or localization before as well. I think this is also, for construction, is very important. And I think there, particularly because you can see hybrids construction approaches emerging, so containerized robotics, for example, the ability to print, so in a way do prefabrication, but on the building site, and then to move that up. It's very powerful if that can be connected to local material production. So again, it's something that is very similar to what is happening maybe with concrete printing, for example, that the materials can be made very simply on site. There is some advanced chemistry that is happening back in the lab, but what's actually going on in terms of the material production on site is cheap and fast and able to be produced in quantity. And I think this is a key hurdle or challenge for materials going into the construction industry, is that sort of scalability around quantity and cheapness, price.
Yeah, price is definitely deciding.
Yeah.
I mean, you as a researcher, you are always quite a few years ahead. I would put it that way, because I mean, you are researching things that might be applicable in the future. Olga, you're focusing on the topic of circularity in design. Although you are years up front, let me put it that way, do you see already an interest on the end consumer side? Is that something you look at as a researcher in terms of, is the society ready for thinking about circularity in building? Is that something you consider?
Well, first of all, let me say that we are 2 steps ahead because of our students.
Yeah.
They are the ones who are two steps ahead from us. So we have this co-learning, thing going on. Yes, of course, because circularity, we tend to say, requires systemic change. That means it's not a matter of developing a technology, it's not a matter of finding the right material, it's actually everything. So it's both, but also how to raise awareness in regard to the use of new materials, to develop a new let's say, vocabulary of aesthetics, because these materials need to be also accepted by architects and their clients. So it's also about making policies to advance and promote different construction methods and different materials in construction, and to also enable certifications. There is a huge amount of stakeholders involved in the buildings, anyhow. Circularity challenges these predetermined, pre-described, let's say, interdependencies, and reshuffles the box. And in that sense, you cannot just focus on the allure of digital technology like additive manufacturing, for example. You have to question every time what is the added value of that technology to what you want to achieve, to your ultimate objective. So what is that?
And for each and every stakeholder.
And for each and every stakeholder, and for the person coordinating the design process or the building process, every choice needs to be contextualized. So what is actually changing is that we're not trying to develop one-size-fits-all solutions, because this is never going to happen, but we are trying to advance our understanding and knowledge across the different topics, just to be able to make the right decision each time. So it's a different thing. It's not like, oh, take this, it's going to work. No. Every time, every situation is different. We need that kind of knowledge from materials and construction to be able to make the right decision.
Sounds like it takes another few years until we see that.
I think there is a phrase I always identify with. We have work to do until the end of time.
I mean, Oliver, the 7 years with Beam now, how do you see the progress, and what kind of outlook creates that for you? I mean, you have observed now 7 years of development in this field. How is the future?
Yeah.
How fast?
As I mentioned earlier, the 7 years were amazing in a sense of how fast things developed. regarding to your last question, where are we in research? Yes, we might be a little bit ahead. We have the luxury to work on stuff that does not need to be economically performing. Yeah. However, that needs to be transferred. So one thing that a lot of universities look at is how can we help startups to get our research into industry. That is something that also then feeds back into the research, of course, yeah, because you're faced with problems that you wouldn't envision in your lab. That's an interesting way to collaborate and exchange. And then there's a political dimension, which is important. If you look at EU taxonomy, if you look at the German Koalitionsvertrag, what our government agrees on doing in coming years, it will change the requirements for an industry. So you better gear up for that as an industry to see what's coming in a sense of using resources, of using materials. We are at a point where tax models will change and CO2 emissions of materials will play a major role. And this is a moment where additive manufacturing could be suddenly economically valid because if you design it in a smart way, you then use only the material you really need for a building, for load bearing, and for all the different requirements that a building has.
Yeah, might be the only way, like we heard yesterday from Deutsche Bahn that say whatever train they buy in the future, they need the spare parts for a lifetime. So this is the only way to realize that is implementing additive manufacturing in this case. So probably this is really a way which then would lead also to biodegradable materials, because this might be a way to prevent another CO2 increase. Nadja, this leads to, let me tell you a quick story. Last weekend, before I went here, I met a friend and we talked, and he told me in the past he worked in the wood economy, okay? So, and wood and construction. And he said for decades now, they are discussing about building houses, especially in Germany, where we can do it like circular, because sustainable, because we have the volume of wood we would need for building. And it was never achieved due to the fragmentation of the industry. It was never, they still build the old traditional way. What, besides the legal aspects, must happen that we see more and more projects in reality?
Well, I think actually the legal aspect and what researchers can do for it is pretty important. Oliver was describing how can you collaborate with the industry or industry partners to get that through. And in 3D printing, there is a huge issue about regulations, right? We have new materials, potentially new ways of shaping materials. How do they perform? And I think research is also there to provide the data so that we're kind of further and further able to guarantee we know what's actually going to happen. So there's currently a lot about how does a 3D printed material for construction performs alongside like 10 years, 20 years, and how can we do a model of how printed materials react when we can structurally in comparison to when they're shaped in another way. And with these models, can we sort of work with certification institutions so that we get through. And I think for the sustainability aspect, it is also very close to that. It's about can you assess the performance of a material so that when you take it away from a construction, because it's a modular one and you're able to retake them away, if I put it somewhere else, then how does that work? And can I sort of, as a researcher, provide information that guarantees we're able to do it? And as for the structure of in the industry, it's a big question because it's one of the advantages probably also in terms of sustainability. We were talking about these many little companies, and if you envision things as a network because you want to work locally, then it's actually a pretty big advantage to be able to have that kind of tiny distributed structure. So there's a big question whether you would like to push towards larger companies that would be able also to afford moving forward new technology, which is always expensive, or if we kind of take advantage of that distributed structure to move to a more sustainable model.
Very good. Or they are forced then, as Oliver said, by legal restrictions. Oliver, at Beam, do you discuss then standardization where you make like proposals to the regulations, or that's something like where you try?
One thing that we discussed in the last years was the challenges of recreating always the same quality. If you print, you have to make sure that if that becomes a product, it always comes with the same properties and the same performance. This is something we look at. The political and the legal dimensions is maybe a good suggestion for BEAM 2023 to get into.
I mean, we need to speed up. Nadja, you mentioned like the modular way and how does the material behave at another place, for example. Paul, is that something that, how can we research on that? That's just a question for interest. Like, let's say you build in your biodegradable material, then Nadja says, oh, let's try it in the south of France, for example. Other climate condition, is that something that is in undergoing testing? And I try to imagine it's nothing you can do in a lab. You need like corporations. Are you internationally then cooperating in testing those materials, or?
Yeah, that's a very good question. And I would say that we are aware, very aware of those issues. And it becomes even more complex the more you think about it, because of course there are regional differences. A material can behave very differently in two different climatic regions, but also the constituent ingredients of that material can possess very different properties. The strength of fibers, of biofibers, can differ drastically when those fibers are grown in different locations.
Absolutely, yeah.
And then temporarily, I mean, just like wine, you can have good seasons, you can have bad seasons. Yeah, we have, and I think the further you dig, really this. I mean, it does also suggest either developing, either sort of expanding the ways that we consider how we characterize and standardize these materials to allow them to come into the construction industry. This is something that certainly needs to be addressed and put in focus, both on a regulatory but also in the research perspective. But I think it is still, I mean, it exists for timber, for example, and more standard biomaterials. We have broad classification systems that allow that to happen, and there's, I think, a similar sort of set of procedures that need to be created to enable the diversification of those materials. But I mean, at the moment, from a research perspective, it's actually quite productive and interesting, because even though someone may have done a particular experiment, made a particular material, created something on one side of the world, that does not mean that it would work on the other side of the world. And that kind of replication is very healthy for the research community.
Yeah, is there an international exchange on that? Like, you call Paul, let's test whatever?
We are trying to establish one.
Yeah.
And where I come from, TU Delft, we have a very, we are very determined into bringing these different discourses together. So we have the Circular Built Environment Hub, Professor Tillman-Klein is leading. And there we're trying to establish collaborations that are for now interdepartmental, but also cross-faculty. And through the CB Hub, which is like a critical mass of researchers, we're trying to reach out the rest of the world. So cross-level education, but also other institutions. We recently had a symposium on circularity, inviting researchers and professors from all affiliated institutions, let's say, to discuss how they go about in their education. But we do the same thing for research-wise. Interestingly, and it also relates to the question you asked me before, I don't think it's possible to transition to a circular built environment unless we actually learn how to work together. Yeah. So far, industry engineers have learned how to be competitive to one another. That needs to change, and it needs to change radically, and yesterday. So the thing is that we cannot afford to try out separate things and doubling the effort, whereas we kind of need to align forces to get there sooner.
But that's an interesting topic, because when I talked at AMTC with metal 3D printing researchers, they had the problem that international cooperation is always a little bit limited due to funding. For example, as you mentioned, would be great to have an experiment with your material either in Denmark and then, I don't know, in France, for example, or in Thailand or in South Africa, wherever. So who is then paying for the research then on the other side of the world if there's not exactly the same program funded? So how is that an issue with funding in your research?
We have very close ties with the industry at TU Delft, and interestingly we had this prophet, and there was the president of the VMRH branch. That's the facades branch organization association, and it was she who said that first we need to start work in a way that's not competitive to one another. And we're talking about the whole facade branch association. So, yeah.
So this would lead then to quite of a important responsibility as role models. As you are researchers, you have the new students in place, which will make the next generation of architects, construction expert, material experts, whatever. How do they? Is that something that you implemented in your teaching to tell them, listen guys, in the future it's not longer I want to be the best architect in the world, it's more about...
Definitely.
Yeah, how do you do that?
Yeah, it's mostly because we're dealing with issues that are very complex and there is no single answer. We don't even, sometimes it's not only that we don't know these things, but we cannot even describe them in full. So how do you go on teaching something that's so uncertain and so complex? And how do you make students get inspired by this and not discouraged? So that is a hard task. I think it's good to frame education as a hopeful stance, as the practice of hope. I think where we stand at the moment, we kind of need this younger generation of professionals to take a hopeful stance to what is going on in the world and to coil around ideals and principles before technologies, if you ask me. So.
And to remain positive, I think this is another important topic. Yeah. Nadja, I mean, you have X-Tree still exists, or is a company that you're still driving. So you could then be a role model and tell the future architects, look, we are doing this and that. Is that something, the role you have to play very often, that you give speeches on your activities there? And
a bit. So what we've had a lot of students visiting our facilities to kind of see how that works, which is always pretty interesting. It's what Olga was saying, they're a new generation and they're a lot more strict than maybe we were at that age on sustainability issues and on saying if it's not sustainable then we're just not doing it. So it's also about sort of questioning, figuring out. At X-Tree we've been looking at new materials, so geopolymers or clay or things that may be potentially more sustainable than concrete to print, and how exactly you can put that in place, how you can either reach the same performance in terms of scale and structural performance with other materials, or maybe also, as was hinted a little bit, can we just rethink how we construct? If like clay doesn't reach the performance of concrete, then maybe it's not that bad because maybe we can make it work in terms of scale. Maybe we could just do with smaller pieces and then go on. And yeah, it's quite interesting to see how visits have intervention. It's not only about showing them what we do, it's also about listening at the way they kind of hint towards and the things they believe should be done. And yeah, balancing how we progress also based on their intake.
Let me ask Olga another question, because this is really interesting. Yeah. As I experience researchers, once I talk to them, there is also a way of competition, because of course you want to be, depending on the research you're doing, you want to be the first to publish, or you are on an innovation, whatever there is. So sometimes, I mean, we are not, let's call it, we are not the generation that learned too much to cooperate. I mean, we are rather forced actually to do so. So the new generation coming up, would you consider, as Nadja said, that sustainability is a must for them? Is that something you feel? I mean, you are close to them, or are they saying, most of them, it's not that bad as always described in media?
Well, I can't say it's a must, but it's, let's say, related to the other fascinations. It's embedded in other fascinations. And we're not trying also to promote it as a must, in the sense that it's not a mandatory. It maybe is, but we as educators cannot force sustainability or circularity on anyone. What we are trying to do, though, is to enable them to, let's say, intertwine their own fascinations within the greater context the world is in today. And then comes circularity, there comes sustainability, and then there comes the choice, which is a very political choice, like Oliver said, to decide who you want to be in this world. So pursue the fascination, but in a way that makes sense to others as well. And in that regard, I think we're doing very well.
Sounds good to me. Paul, you mentioned it several times the economics of materials or the whole thing here, as due to a study that I just read from Executive Consulting, I don't know them, was on 3D Native. The market should rise from 503 million in 2020 to 6.5 billion in 29. So there might be some economic interest on the side. How do you see that in terms of economic scale? So is additive manufacturing increasing with these impressive numbers, in your opinion? What needs to be done to get there?
It's a difficult question because really we also want to reduce our material use. I think as well, yeah. So
I think it's more about the construction market and the use of additive manufacturing.
Yeah. Okay. Yeah. So in that case, I mean, I think that the construction is characterized by the need for for a lot of material. Yeah. And I think this is so. And of course, we are. There is a great need for development. And I think where additive manufacture can play a role is in reducing maybe that overall quantity of material, and perhaps also diversifying the material resources that we are able to use
to a better result. Oliver, I mean, it's if we talk about additive, it's always if we want to speed up, what are the advantages in real use compared to traditional methods, right? So if I read through the advantages of additive manufacturing in construction or building or in architecture, it's a really long list. But it doesn't mean that it really gets realized because most of the companies out there, and they are fragmented in your segment, they are comparing it, and if it's not really the same price or even cheaper, then they say, okay, I don't see the main advantage. Is there in the near future an economic advantage in using additive manufacturing if we look at the different materials, if we look at different designs, Nadja, that we can use? I mean, probably we can build into mountain parts where we couldn't build before because we can use additive manufacturing. Do you see that in the near future, that the building industry, at least for specific situations, says there we can use additive much cheaper or more economic than the traditional approach?
Yeah, the question is what is part of that calculation, right? Currently, we don't pay for the costs that we create when we use concrete, and if we would calculate the amount of CO2 emitted by producing cement, then concrete would be much more expensive. If that becomes a reality, I think the way we build will change. Mm-hmm. And there's probably a difference between this aim, you mentioned that, for being faster, being slightly more efficient in what we do all the time, or if we want to have other effects, if we are effective with 3D printing. Yeah. And I'm convinced that that means that we have to rethink the way we design and we materialize. And again, if there's the political and societal context around it, that will have an impact on construction costs. So my hope would be that, maybe the way we build today becomes more expensive because costs that we create for future generations are part of that calculation.
Yeah, very good.
Which then gives the chance to build differently through additive manufacturing.
Nadja, we discussed briefly in our briefing about the life cycle assessment of buildings, especially if it comes to sustainability. I mean, the problem is we are talking about things that last, I don't know, 50, 60 years. What is the current status on that? Probably whoever wants to answer, but I would ask you first, Nadja. We talked about models that are tried to be used, but this is a question I got from this friend from the wooden industry. The first one is, what is then, where is additive manufacturing more sustainable? Because you can always say we use less material, but probably use more energy. This is always a main calculation. So how do you see the status on that?
So I think the main question now for additive manufacturing in the built environment is that usually if you do a life cycle analysis for a building, you almost only consider the material the building is made of, because every construction process has been extremely optimized. The tools can be reused so many times that their impact is very small compared to the actual material the building is made of. But through 3D printing, we digitalize a lot of the process. So the question becomes, is my process, my tools, are they still so negligible compared to the building material itself that I cannot just not calculate them and look just at the materials? And one of the big questions now is to basically make enough LCAs of different situations, of including the tools, to be able to figure out in which cases we can keep that assumption and in which cases we actually have to consider the impact of the printer itself, basically. And then comes the question, how are we capable of integrating those tools enough in construction processes that we're able to say, well, yeah, certainly my printer has quite the impact, but maybe I'm using it enough times that it becomes worth it. So we need a lot of data because LCA is usually a very specific, very powerful, but very specific tool. So the status now is to kind of be able to figure out if that trade-off between process and building material is different in additive manufacturing for construction, or if it's similar to what we already know.
Would lead then to my question, who is doing that? Is that part of your research? If you are looking at the material, is that something you include, or is a clear part of your, let's say, of your target, considering, let's say, at least models or calculations on sustainable in the...
Yeah. So not for us. I think more what is part of our target is to because I think there's a calculative dimension and then there's a social dimension. Yeah. And that is certainly within our targets, which also is about changing expectations around buildings, changing expectations around the lifetimes of building elements and building products, and understanding also relations, I think, actually, between occupancy and the buildings we inhabit. So in our research, at least, we do not do so much LCA, because we are not producing those objects, and our research projects do not last the length of time that it would take to really test them. But we are able to explore the social dimensions, and this, I think, is the other very important aspect.
Very good. We are coming to the end of the session, which is a pity because I just grooved in. So thank you very much. Excellent panel here. Thank you so much for the insights. I highly recommend to the audience and to all that have the time to go to the BEAM Symposium. Seems to be something that has to be visited and to explored. Thank you so much for giving me some insights, for answering the question. Although I'm not an expert, I hope you apologize that. It was great to have you here. Thank you so much, and good luck for the symposium and your future work. Thank you so much. Big applause for the panel. Yeah, ladies and gentlemen, we are doing a short highlight break, and then my colleague Frank will say hello again with some expert insights. Enjoy and keep on watching. Bye-bye.